Hello there, this is Vincenzo Lombardo, and today I'll be demonstrating my Humber College second year electromechanical project, which I did solo. And this is an RFID product and inventory system, which consists of a conveyor belt here, which includes two IR through-beam sensors for detecting location, along with an RFID card reader here. It also has some containers for storing sorted products and a 4 degree of freedom robotic arm with a spring-loaded vacuum suction cup here. I'll bring it a little closer now. So I've got some physical start-stop buttons along with power indicators and power switches. And this is my touchscreen HMI that I developed. It shows the current state of the system, what step it's currently doing, and the inventory. The system can be started and stopped using the HMI or also using the physical buttons. I have these little products here that are color-coded, and inside each one there are some MyFair Classic RFID tags, which has the product information, with the exception of these white ones, which I'll be using to demonstrate unknown or rejected items. And now I'll do a quick demo of the system. So I will start the system. I'll take one of these blue ones, I'll put it on, it will scan it at end of line, it will stop, the robotic arm will come, turn on the suction, and sort it into its appropriate container. I'll do one of these ones now. I will show you the HMI in a minute as it's running. I'll throw an unknown one on. I'll put one more and then I'll show you the HMI. So I'll bring it a little closer so you can see it's currently running. So far I've loaded one of each product into the system. So now I will put another one on. I have these little laser cut pieces which will center the product, and this one at the end which will bring it into a set location for this. So I will now put a product on as you're watching the HMI. So you can see it says scanning product. It will show the product data. At end of line it will stop. It will come pick it up. You can see that the product's been updated to an inventory 2. And I can also do it, I can issue a stop signal and it'll stop it. Same thing. If I issue a stop command while the robotic arm is in motion, it will finish its current cycle and then it will remain paused until the next start issue is command. So now I will show you the back side of how it's all working. So this is the back side. So the conveyor I rebuilt from my first year project, which was based off an Arduino Nano, and I've upgraded the drive controller in here to a stronger stepper motor driver for the NEMA 17 conveyor motor here. Except I have my IR emitters and receivers here, along with my RFID scanner, which all run down. Here I have the Raspberry Pi, which is the main controller, run to a breadboard breakout with a couple of pull-up and pull-down resistors for some of my signals. I've got a I/O terminal block expander. This Ethernet cable here is running to the RFID scanner. These 3 cables here are running to some of my distribution here, which is my start, stop button, and conveyor enable. Along here I've got a 5-volt and a 12-volt DIN rail power supply, which run through the power switches here and feed my ground 5-volt and 12-volt power distribution. I've got my 120-volt power distribution for my 2 power supplies here. I've got a step-up voltage converter bringing the 12 volts up to 24 for the drive motor here. And in here there's also a 5-volt regulator to power the Arduino. Here I've got an I2C Adafruit servo driver for the robotic arm, along with a 4-channel relay, which I'm only utilizing 2 to control my vacuum pump motor here, and my 2 normally closed air solenoid to release the vacuum, and those are terminated back there. I've got some pneumatics fittings which come up to the suction. Like I said, here's the other side of the inventory for products seen unknown, and that's pretty much the system at a glance. I quickly put together a quick little schematic of some of the wiring. So I have my power supplies, my through beam sensors, my relays, my RFID reader, and we've got the Arduino with the stepper motor driver, stepper motor, the step-up converter, and the voltage regulator for the Arduino. And up there we've got the I2C servo driver with the servos. And that's pretty much it. That's a quick overview of the system. And like I mentioned, this was all coded, minus the Raspberry Pi, was all coded through Python and making use of multi-threading to automate the whole system. Hope you enjoyed.